So yeah, thanks again, Dave. This is a presentation on Beebjit, a BBC micro emulator I've written recently with a focus on trying to go fast. So briefly, just a little bit of history on me and the retro journey I've had. It all started, we think, age 9 or so, with the Acorn Electron, a very iconic machine. I think what happened is Acorn had that manufacturing wobble where they had a bunch of surplus after one Christmas due to, and so these Acorn Electrons were going super cheap, and my mum just picked one up on the off chance I might find it interesting, and I did. That was upgraded to a BBC Master Compact. Loved that machine with its crazy 3.5-inch drive. And then later went the Amiga route, also a very interesting machine. I went on to have a career in security, probably influenced by my attempts to defeat copy protection on my BBC Master Compact. The fields are kind of related. So I kept that going with a career in security, and I'm currently on an indefinite break from that, which means it is retro time. I have time to fiddle around with the retro stuff. Obviously, I've written Beebjit, and I'm talking about that now. I've contributed to JSB. I've enjoyed that a lot because it's probably the most accessible emulator running in a browser. I've helped a little bit with some of the emulation and video accuracy in JSB. I'm very interested in disk preservation and disk copy protection. So I've recently released the HFE Archive of protected disks, still working out what to do with that and which direction to take it in, building on Bill Carr's excellent work, archiving his excellent collection. So a bonus image, managed to find this picture of me, age unknown, but it's with my trusty BBC Master Compact. Look how bright it is in this picture. No retro bright needed here. There are some Easter eggs in this picture. So there's on the floor. I was very untidy as a child, obviously. There's a micro user editions on the floor. If you zoom in, you can see in the waste basket there's a lot of Walker's crisps. I think like an excessive number of Walker's crisp packets. And on the screen, I think what you can see on the screen is an enlarged character from Magic Mushrooms. I think the name of that character is Murphy. And I was fiddling around with making my own game. And I had a habit of starting games, getting as far as the title screen, declaring they were going to be great, and then getting no further. So it's nice now in order to finish things like Beebjit. So the what and the why of Beebjit. It was not my intention to write a BBC emulator. We have a lot of BBC emulators, and a lot of them are very good, so we probably don't necessarily need another one. But what I was doing is, after a particularly tedious day at work one day, meetings and so on, I got home and just had to fiddle with something low level. So I started exploring if you could translate 6502 code into modern Intel x86 64 code, and what it would look like, how directly you could translate it, and just a really technically fascinating project. Actually, it got me hooked pretty quickly, and I got it running pretty quickly. And then once you got it running, you want to run something useful, some real code. So obviously I chose the BBC as a source of code. Initially basic programs, because you don't need much of an emulator to run basic code. Just running little programs to see how fast they would go. But then before you know it, you think, well, this runs nicely, but this should be making sound. I'll just add a little sound driver. And then you get bored of typing stuff in, so you think, oh, I'll add a disk driver to load things from disk. And then suddenly and unintentionally, I had 80% of an emulator on my hands. And at that point, I thought it was worth pushing over the finish line. So I did. So the goals of Beebjit were to be fast above all else, because of the translation was fast, so I wanted the sort of surrounding peripherals to be fast. Another focus became accuracy. I got very interested in accuracy of BBC emulation when working on JSB. I've tried to carry forward what I learned into Beebjit, so it should be pretty accurate. It also, on the sort of plus list of things it does well, it actually has robust support for protected disks, and that means that you have to emulate the disk controller accurately. and you have to emulate the disk drive accurately. The way the disk drive rotates, and at any given time the disk is rotated to a certain position in the drive and relative to the drive head. If you don't emulate that, some protected titles won't load. And this is a prerequisite to running the HFE protected disk archives. One of the reasons I released Beebjit just recently is I wanted, when releasing a protected disk archive, I think a prerequisite to the release was having an emulator capable of actually loading and running the protected disks so that people can enjoy them. So now your options are for these protected files. You can load them on a GoTech, and then they'll load on a real BBC, and you can use Beebjit, and you should expect them pretty much all to work. There are some things Beebjit does not do. There's some good reasons why Beebjit might not be the emulator that's most suitable for you. So it's missing advanced peripherals. So anything that's not bog standard back in the day, like a tape drive, a disk drive, a little bit of sideways RAM, anything not on that list pretty much is not emulated. So the focus is on sort of core BBC Model B software and games that ran on vanilla machines that most of us had back in the day. There's no BBC Master support yet. That's something that I might consider adding when the core BBC Model B support is running really well. There's no fancy GUI. You've got to sort of roll up your sleeves and start typing to get the most out of this thing, which is actually currently a philosophical decision, because that's the way the original BBC was. You'd have to roll up your sleeves and type something, even to just load a tape. But there's no Mac port yet. So if you want to run it, currently your choices are Windows or Linux, which is what I developed. So just briefly, some results on the speed. Clock speed is a test I like to run, because you run it, it spits out a figure of how fast you've managed to run. The current record machine for running clock speed on Beebjit is actually one of Matt Godbolt's machines, the author of JSB. He has a 4.5 gigahertz machine, bit of a beast. Managed to touch 15 gigahertz on a couple of subtests. That's the current chap. But there are faster chips out there, so if you can beat this with your machine, please do so, and I'll update this picture. But yeah, we've managed to clock this thing into the gigahertz range for most things. This performance represented here, like a combined average of 12 gigahertz. Don't expect everything to run at that speed. Basic programs run at this speed because basic programs are not interacting heavily with the peripherals, and in fact, the peripherals aren't synchronized in this fastest mode because they don't have to be for basic programs. But if you're running games where the timing has to be spot on for everything to work correctly, maintaining things in sync will drop the speed perhaps to maybe the 4 gigahertz range for most games. And there are some corner case games that do weird stuff that can be optimized, which hasn't been done yet, and will go much slower. Since Tricky's on the line, anything Tricky wrote, you can expect is doing weird stuff, and will currently go a lot slower. But I hope to, since I love Frogger, I hope to optimize for Tricky's video tricks in the near future. So, quick couple of visual speed demos. Let's bounce out of here. And oh, that was loud. And we're going to load Palace of Magic. I'm presuming that the looking at my screen is still working. I'll just keep going. If you can't see the Beebjit screen, someone shout, but I'm assuming you can.
It's all good. It's all good. It's working fine.
Excellent. So we're going to load Palace of Magic from tape, because back in the day, those of us that had tapes, like I did on my Electron, no pain of waiting for a game to load. So we're going to load Palace of Magic from tape in fast mode, where it goes fast when the tape motor is on and goes back to normal speed when the tape motor is off. So let's see how fast it loads the title screen. Oh, there it is. So you press spacebar, it's going to do its nice fade thing, and then load the main game. How long will that take? Oh, and there it goes. So that gives you an idea of how fast it can go when it's trying. One other demo that's visually quite nice is these games that have attract modes that sort of cycle through some screens on the title. If you kick those into fast mode, which I can do by pressing Alt F, you can sort of see the difference in normal and fast mode. So I've kicked it into fast mode, and it probably won't come across the video share my screen on Zoom, but it's just a blur of screens, and I think quite visually appealing. I don't know, I quite like it. In the background here, I've got the performance monitor going just to show you how fast it's going. For whatever reason, that's slower than normal, probably because of the video chat, but it's like hitting about 2 gigahertz, so about 1,000 times normal beep speed. I'll shut that down. I'm going to quickly paste a YouTube link into the chat, which, as part of a collage, has that video, just so that you can see it without the sort of slow frame rate of the Zoom video. Hang on, just in case. Okay, it doesn't. The way Zoom works is looks like I can't get access to the. Oh yes, I can. There's the link. And the other demo I wanted to do, just quickly, not so much a speed demo. This is a demo of loading an original protected exile disk, just to show you that this works. The reason I think this one's interesting is because it looks a little different to the disk images out there on the internet that you might play in on BBC Micro, because they've been cleaned up. The original load had quite a messy load. So as it loads past the title screen, you'll see it actually loads the game code on top of the title screen, and then you sort of see it run through a couple of iterations briefly of decryption. Using the original protected loader was heavily encrypted, and you visually see it decrypting. And the reason this is interesting to me is it just brings back the nostalgia of loading it myself when I was a kid, like seeing the actual noise come across the screen, and it decrypt itself. And that's just an experience I wasn't finding myself getting with some of the modern hacked emulated copies. And then, of course, another thing you won't find on the modern hacked emulated copies is the sort of enter the word from the novella. I think we'll move on. I won't put it in, but I bought a prop along just in case we had time for me to actually type in the word. So how does it go so fast? So I mentioned that it works by translating 6502 to x86-64. It's one of those things that sounds pretty simple at first, and it is simple at first until you start hitting all of the problems. So we've got a bit of 6502 code here on the lower left. It's just a simple loop that's just sort of checksumming a page byte by byte in a loop that will go on for 256 iterations. And as you can see, there's a one-to-one correspondence between 6502 instruction and Intel instruction, which is kind of cool. And this Intel code on the right, this will motor along on a modern processor. The modern processor can do more than one of those things at once on a given clock tick. It'll predict the jump accurately and just really motor along. So things are looking good for performance. But you'll notice there are a bunch of things that it's not doing that it will need to do if it wants to be accurate. So on the 6502, an interrupt could come in at any moment after any of those instructions, and you'll see there's no interrupt checking. So that's a problem. It's also, in parallel to the 6502, there's the timer chip. The VIA timer chip is ticking away, and that needs to be maintained accurately alongside, in lockstep with the 6502 code. Otherwise, you can forget loading Kevin Edwards protection. So there's some missing things there. So actually, the code shown here isn't quite the full story. Let's just add in this block of code here. So before every block of code, to enable the block of code to run at full speed without worrying about any of that, there's a little check. What this little check is saying is anything interesting due to happen in the next 9 cycles. And most of the time there's nothing. This thing does 2 million cycles a second, right? So most of the time there's nothing particularly interesting due, and therefore you can motor along at full speed, running blocks of code at very high speed. So that's the trick to Beebjit speed. It's just to understand when something is happening and when it's not happening, and to motor along at full speed in the common case. Of course, nothing is ever quite so simple. One of the most annoying things about the 6502 instruction set is that some of the common instructions take a cycle longer or not, depending on the data inputs, depending on whether the data inputs result in a page crossing. So now you see that if a page crossing might occur, suddenly that one instruction that translated cleanly to one Intel instruction, it has to explode to at least, well, 4 in this case. I'm going to cycle back and see if I can optimize it, but that's kind of annoying, and that'll slow you down for a lot of common instructions, where to be accurate, and again, if you're not, stuff won't work. To be accurate, you have to do a bunch of extra work. Another thing that probably is the thing that's most important to solve, and solve fast, is self-modifying code. So self-modifying code on BBC games was rampant, ranging from the protected loaders through to just normal code would do it just because it felt like it, and games would use self-modification heavily for like sprite routines, to squeeze every last cycle they could out of sprite routines. Actually, this game Exile has tons and tons of self-modifying code, because they were pulling all of the tricks in the book to get things to go fast. So what we could do is every instruction, we could check if the instruction has been modified away from under us, but that would be really slow to do something every instruction. So what we do instead is every time the 6502 writes to a piece of memory, we actually look up if anything is there. Or we don't look up if anything's there. We just unconditionally put a stamp on the JIT code saying modified, and if the modification, if you do hit this case where self-modified code hits, then actually this last line on the screen here, this is what is stamped on top of code. It's like a little call out that if self-modified code is detected, it calls out to the compiler to recompile the code. As you can see, to support self-modifying code does mean that every store explodes from one instruction to 5, which is a bit of a shame. But it does move along pretty quickly. One thing we want to avoid is constantly recompiling code. Recompiling is very slow. So the compiler has some smarts in it too, to work out that if it's recompiling because like it's a sprite routine and the modifications are modifying addresses that are part of, say, the operand of a 6502 opcode, then it can recompile that opcode to use a dynamic version that actually loads the opcode from RAM and then can run at full speed without taking more recompilations. And overall, this enables something like Galaforce to run at 4 gigahertz with no runtime recompilations, despite self-modifying code going on like crazy in the background. Just one more thing that's kind of painful. One of the instructions the 6502 has is the indirect Y addressing modes, and they're actually quite impressive instruction. That it actually does a really points out by doing 2 dependent reads in one instruction. That's another instruction that will explode to multiple instructions if you want to implement it, translate it, which is a shame. It's a very common instruction, and it looks like exploding one instruction to loads, however many that is, maybe very slow, but fortunately things balance out. Modern Intel processors can actually run a bunch of instructions per processor tick, so it all balances out to running running very fast. So I could do an entire 1 hour talk just on how we get Beebjit fast, but just to move on and cover some other things. Anyone that's written an emulator will attest that when you write an emulator, you will uncover some crazy bugs. And I've just picked 2 here to quickly talk about. One is a demo, can be demoed in Camelot. We're going to quickly boot this. Camelot, I don't think it was given a standalone release, or at least not originally. I think originally it came on Play It Again Sam 9. Again, this is the Play It Again Sam 9 title screen is just an experience you won't have if you play Camelot using a modern hacked disk image. But this is the original Play It Again Sam 9 disk image with copy protection. Let's pick Camelot. And the crazy bug here is it is loading in the background. I just haven't added disk drive noises yet. So the crazy bug here is it says press space to start. What we're going to do is we're going to press space to start and hold it down. Okay. Now we're going to run around a bit. Okay. And there we go. Notice that on a certain of the frames, when the little Camelot guy is facing right, the left-hand side of his sprite is corrupted. Just one of those crazy bugs where I think the game is sort of trying to rewire keyboard state and messing with internal OS 0-page variables, and it does it in a way that that leaves the keyboard running if you keep the space held down, and as the keyboard is left running, it fills up some buffer, and that buffer is where they put this sprite, and it gets corrupted if you do that. Hold down the space bar. I just thought it was a really cool bug. Don't know if anyone noticed it back in the day. I only noticed it because when the emulator is in fast mode and you press space bar, the game starts instantly. So the space bar will always still be down, and you'll always get this bug. I thought it was a pretty interesting one. The other bug is just a talk-through bug on a disk that a game I'd never heard of. It's part of the HFE archive from Bill Carr's collection, a fairly obscure title, but it just doesn't work on a standard 8271 equipped BBC Micro. The loader just fails. I talked to Bill Carr, and he said it worked fine on his machine, and it turns out he has a Watford DFS. And the crazy bug here is that the loader code, the protected loader code, is just has a bug where it forgets to initialize the X and Y registers before calling into the Osword call to load do some disk thing. So an effectively random command is passed on to the disk drive DFS, and it on Acon DFS just is not happy and just hangs. On Watford DFS, it works due to a series of flukes. So if an incomplete command is passed, the Watford DFS just invents a few parameters to complete the command anyway. That's sort of fluke 1. Fluke 2 is that the command it ends up executing is a scan command, a command that doesn't even that exists on the disk controller chip, but is not wired up in the BBC application of that chip because it needs DMA. So the command isn't wired up at all. But if you emulate that command accurately, which is to fail with a certain error code right away, the Watford DFS will just do this thing in a loop and then sort of shrug and return control, and the game loads. And it's just a miracle this ever worked. And I thought that was a really interesting thing to discover. Maybe it worked with a 1770 chip as well. I don't know, but just a very interesting buggy release there. So what are the usages for Beebjit? Micropowered chess is one that I think is kind of amusing. Back in the day, at level 5 or something, it was kind of unplayable. It would take about 30 minutes for a move. Whereas if you run a Beebjit in fast mode, you can play the computer. I'm terrible at chess. I lose terribly, but at least it only takes a couple of seconds per move to thrash me resoundingly. And that's a useful application. Just any basic or any other language computation will probably run really fast, and that's one potential use. I use Beebjit a lot for copy protection research, since it's able to load copy protected disks. And under emulation, well, you can research how those work. But preservation. This is an idea that inspired me, like many things do, by some interesting thread that was had on the Startup forums. There was this really interesting thread called Demystifying Night World, a really game that mystified me for sure back in the day. Just someone was trying to complete it because it was unclear that anyone ever did back in the day. And that person was describing some of the situations you get into and things you could try to complete it as you walk through various rooms. And I wanted to sort of dive in and try some ideas at different points, but there's no easy way to do so. So I'm going to show you a little demo of Exile. This is me playing Exile last night. Oh, sorry about that noise. Whilst that loads, it's loading at normal speed. It's actually replaying just a session of me banging on the keyboard last night playing Exile. So the observation with these emulators is that the only thing that makes an emulator behave differently from run to run is non-deterministic inputs to the emulator, and all that is excuse my ineptness at Exile. All that is just the key presses and the time at which they are pressed to a high precision, and then you've got this replay mechanism. And you get really small files, very small files indeed, that sort of can. That's very loud. Very small files indeed that can represent, a long video, if you like. So what I'm going to do is quickly hit the fast mode, and when that fast mode exits there, that was me solving the game up to the first few puzzles where you get a bunch of keys, you're ready to get the ISA. But that sort of got me thinking that these little capture files of key presses and time, they're like save states, but with an infinite number of save states. So you can sort of exit that save state at any time and take over where the original game player left off. And it just got me thinking, this is just one of those food for thought things. Would this sort of strategy be another angle on the preservation thing? We go to pains to preserve these tapes and these discs, but if the knowledge on how to play these things is lost, does that mean have we fully preserved these games? That's my sort of hopefully thought-provoking question with a possible solution that I wanted to get out there. And of course, unknown usages. A fast emulator really is just a tool. And another question for the community is, when you have this tool, a fast emulator, what are the usages for that we haven't yet discovered? I'm sure there are some. I just haven't thought of them yet. On to the future of Beebjit. The current status of Beebjit is it is actively developed. I'm still enjoying trying to make sure that every single protected loader works. Just this week, as mentioned by Dave, Android attack blew up the JIT engine, which is a pretty cool accomplishment, because it's been a long time since some game was able to do something sufficiently weird and not yet seen before that the JIT engine blew up. It's now fixed. But yeah, I'm actively developing it. I'm going to continue to do so as long as there's interest, either from me. I'm currently interested in fixing everything to emulate everything as perfectly as possible. But as long as there's interest from other people, like using it, suggesting improvements, I'll keep developing it, I think. Once the current raft of fixing protected images is done, and I think it is, I'll probably go and do another round of performance improvements to make it even faster. probably focusing on some of the cases and games that do stuff so weird that performance just tanks. There is a bunch of games where they just do something a little bit strange. Performance just craters. In each case, there's usually a clear path to making it run at full speed. I just haven't done that work yet, and I think it'll be fun to do that. Exile is an example. Like I mentioned, it does a ton of self-modifying code. Not all of those self-modification situations are yet fully handled at full speed. So as you're running the game in the demos we've just seen, in the background, the JIT engine is frantically and furiously recompiling stuff continuously in the sprite drawing routine, I think, just to try and keep things running along accurately. So Exile is probably going to get twice as fast when I fix that. Video 6845 abuse slows things down a lot currently. Looking at you again, Tricky, and Frogger. I love Frogger. That can be made probably 10 times faster than it is currently. So I'll be doing that. There are other games that just slam the hardware registers. That's one thing that's really hard to do fast in the JIT engine, because when you hit a hardware register, that's kind of the business of the BBC to do its potentially complicated thing with that hardware register change. So every time you hit a hardware register, the JIT engine has to stall, has to sort of save its state, it has to restore state that's suitable for calling into C code, call into C code, and then come back into the JIT. And the version of Elite I have does this. It's whilst it's spinning the ship around in the demo, in the sort of title screen demo, it's also scanning all 256 possible key presses. Not that number is even possible on a Beeb keyboard, but it's just doing some crazy keyboard scanning in a loop. So again, that's something that can be made much faster. I'm definitely interested in disk preservation and loading protected disks. I might, if people ask nicely enough, because it's a tricky piece of code to port, I think, but I might port the HFE loading and the accurate disk surface and controller work into JSB, simply because that emulator is so accessible to so many people, just with a single click in your browser. So say expanding bbcmicro.co.uk to be able to, with a single click, launch protected titles would be pretty cool. I might take that on, although it's not trivial. It's a bunch of work. And just suggestions solicited, given that the emulator is actively developed. I'm soliciting suggestions on what to do, and I'd be happy to take on many of those suggestions. Which brings us on to Q&A. I think we're roughly on time. Let me just try and get back to my Zoom screen and see if any questions come in. You can ask over video. I'm now looking at the chat screen if anyone wants to put their question on chat.
I've got a quick question. I've done a lot of work trying to make 6502 straight emulation go faster on ARM, and I spent a while looking at doing JIT, and on an ARM you end up having to flush the instruction cache on self-modifying code. And from your little examples, does the x86 just sort that for you? And
that's a great question. I've just turned on my video. Sorry about that. The host asked me to do so. I must have pressed the wrong button earlier. So yes, the x86 since forever has maintained a strong guarantee on self-modifying code that it will just work. It's documented in the Intel optimization manual that's like 1,000 pages long. It's a guarantee it makes that the caches are just coherent. I feel sorry for Intel because they also guarantee back compatibility, so they're stuck with this guarantee. And it must be really hard to do in silicon. You hit some self-modification situation, and modern processors have like 1 million caches that have to be carefully invalidated, and speculative execution has to be unwound. But yeah, it works. It's guaranteed to work. They even tell you a bit about how it works. Like the self-modification window is actually not one-page granularity. It's like 1K or 2K or something strange. So yeah, it does just work, which is fortunate. And if I ever ported the back end engine to ARM, I'm probably going to have to take care of self modification a little more carefully.
Yes, I mean, I only did some sketches of how the code would work, and it becomes tricky. You just end up issuing lots of ISBs, and you know, they're expensive at the time of day to do. No, good talk. Thank you very much for your talk and efforts.
Could I ask just a question, just one more? Sorry, quickly, but have you got any plans to support any hardware or develop it like that, or are you just sticking strictly to, well, like the plain Beeb?
When you say support hardware, you're talking about expanded BBC peripherals and models
Yeah,
and stuff?
yeah, it'd be really cool, but yeah, probably quite difficult, eh?
So I do want to eventually support the master, the BBC master,
Right.
because of the one big reason is the bit shifters demos. They're pretty cool. They torture the video chip pretty horrifically, and they're just great test cases for accuracy. So if I have master support, I'll have some more tests on whether the everything is ticking along accurately. So I do want to have master support. Is there any particular peripheral you had in mind, like a second processor or something, or if so, which variant?
I'm being a bit cheeky, really, because I think I've talked to you about this before. AMX mouse, Music 5000, things like that. Would that be possible?
I mean, a mouse would certainly be possible. Not
I mean,
much work.
The trouble with the mouse is you've got like the AMX ROM. So you talk about, could you support ROMs in the software, and would it be worth it? You know, people might say it would be pretty cool though.
So ROMs are supported. You can load arbitrary ROMs. Sideways RAM. Sideways RAM is supported. You saw that on the XL demo. It was the sort of wider, sort of the taller screen version.
Oh right, okay. Maybe I could try and load the AMX ROM in then and see what happens.
Yeah, it won't see a mouse, that's for sure. Did the mouse plug into the analog to digital port, or where did it plug into?
Yeah, was it the user port, the AMX mouse? I think it was. Yeah.
I think it's a serial. It's a serial device that used the. Well, my mind's gone completely blank, but the. I've forgotten what it is, but the functionality built into the one of the 6522 lines to serialize data. My mind's gone completely blank, but that's how it works.
I'll tell you why I'm asking. This is probably quite. I'll probably be in the minority. It's, you know, because you can fire this up on an iPad or something, and that opens it up. I know everyone probably hates iPads, but that opens it up to being able to run a BBC on your iPad, which that's quite appealing, really. It's portable BBC, yeah. But anyway, food for thought.
Sorry, the word I was looking for was shift register.
Yeah, runs on 6522.
Wow, that's nasty. Shift register is not one of the few VIA things not supported in Beebjit, and you'll be hard pressed to find.
The mouse doesn't use serial; it's a quadrature device, just on parallel ports.
Yeah, that'll be painful if something turns up that needs the shift register. That would be a bunch of work.
I don't think anything's connected to it.
Not much uses it.
MCs use it. That's why I wanted it.
Or what uses it?
MMC devices.
Oh, really? Okay.
Since I wanted to play with those, I wanted to simulate those.
I mean, bribes in the form of beer are accepted.
I'm wondering if, whilst you're investigating why this thing wouldn't work, the tape version of Android, it wouldn't work in Beebjit originally, and it would, as if you heard that during the last talk, during Paul's talk, it wouldn't work on my issue 3 BBC at the time. It would just hit that awkward block and stop loading, I think, of the second loader file. Can you actually, have you got any hints as to what might have been the problem with the BBC, you know, what was the problem with the software that was causing the incompatibility? I'm wondering, is it something that could be repeatable on particular Model Bs, because obviously there was all sorts of motherboard revisions, some made in Hong Kong, some made, you know, all over the place. Have you got any clues?
So the thing that was blowing up in Beebjit was just a Beebjit specific thing I hadn't got around to sorting out yet. It worked in the interpreter mode, but not the JIT mode. And what it does, that no other game I've found has done, is it actually wraps around the 60-bit address space using an indirect Y addressing mode, and I just hadn't got around to sort of truncating that in the JIT engine for that specific addressing mode. So it would walk off the end, and it's designed and Beebjit's designed to explode and halt the moment it sees something strange instead of continuing inaccurately. But in terms of what it could be back in the day, one thing I would look at is what ROMs you had installed, if any, in your BBC.
This Doctor, ironically, this Doctor, which was another of Paul's. So.
A lot of the protected loaders for tape, they, like in the middle of loading, they'll have a sneaky little look at your ROMs, and they're particularly interested in whether you've got the replay ROM installed, so that you could hit a button and just save off the memory of the post decrypted game. So they're having to poke around the ROMs all the time, and if they see replay, they'll just crash or bail. So it could easily be a ROM that you have in there.
Yeah, I mean, this predated. This was April 1983. I think it says on the title screen, so it predates replay. I'm just wondering if Paul knows whether was it some copy protection that did Computer Concepts ask you to put into the game, or can you even remember?
I put some protection in which amounted to running some illegal instructions, which jumped over a certain number of instruction words. There was something along those lines, but much more than that. I don't think it could. As far as I know, Computer Concepts didn't add anything else. This was something I wanted to put in because a friend of mine had given away a copy of the game without protection, so I was really keen to make sure that it had something in it. And all it really meant was that it would be very hard for you to sort of stop the execution of the initial basic loader before it got into the assembly code, something like that. I can't remember the exact details, but it made it very hard to trace and step through what it was doing. So it was about using illegal instructions, essentially. That's what I remember, but maybe there was more to it.
I've got my notes up here. It uses a very unusual instruction that's illegal called load A and X, which is one of the only times I've seen that instruction. In some modes, that instruction is not even stable on 6502 processor.
Yeah.
The mode I've got here noted is okay, but some modes you get different results even from time to time on the same machine.
Yeah, I guess that's why they were illegal. Yeah.
I mean, this was a long time ago, and don't worry, I haven't got this BBC anymore. I don't care. We gave up on it in the end. It had a lot wrong with it. And I just remember, I think on the second loader, it would go loading, data block 00, 01, and then you'd hear this really odd sound from the tape motor, like a real low-pitched click, and that was it. It gave up. It didn't want to know. It wouldn't load the rest of the game. So, but anyway, thanks for your insight.
Do you remember what your grandmother's Beeb model was? Like what board number?
I'm not sure. I've still got it somewhere. It's actually one of the ones that I took with me to Singapore. I remember telling you I took some Beebs out to Singapore for a science festival once there, and it's one of those. But I think the tape was worked on pretty much every other Beeb I've tried. Not that I've tried lots, it worked. I must have tried it on another 4 or 5 Beebs, and it worked. It just didn't work on ours at the time. So our home Beeb at the time.
You had a bad Beeb.
We did. It was a very bad beep. We took it to Fluid Technics a couple of times to repair it, and even they gave up on it in the end. So yeah, it was time for a PC, sadly.
If you had a Back to the Future vehicle, you could have got it fixed easily.
Oh yeah, now just take it along to an Abug. Yeah, yeah. Well, maybe not this year, but anyway. Right. Yeah. Thanks, Paul. Thanks, Chris.
Can I ask a really Beebjit question? When you compile an instruction, do you compile a whole instruction, or is it per cycle?
Let's see. Yeah, the instruction is compiled in its entirety. It's actually the compiler is actually very, very, very block based. So we'll actually compile a run of instructions that are guaranteed to run as a block. That's why it sort of checks that nothing interesting is due to happen before running a block, and then it doesn't have to worry about an interrupt coming in the middle of some optimization. And in fact, the fact that it is compiling a block of instructions that are guaranteed to not be interrupted means it can do optimizations between those instructions. Give you a quick example, like the BBC had a shift instruction, right? A LSR, logical shift right, and you can only do one shift at a time. So you'll see runs of like 4 of them in a row in code, and you can squish those down into a single income instruction, and Beebjit does so because of the block-based model and the fact that it's guaranteed that sequences blocks are not interrupted.
And so the converse of that then is I've been doing something. I've sort of unoptimized BM to test out some cycle stuff on the Blitter thing, and it's the opposite way. It's like if you in the normal instruction cycle processing in like BM, you do a whole instruction and you kind of worry about where the hardware is at the end of it. How do you keep the hardware in sync of where you are with the instruction? So say if I was shifting screen bytes in that run of shifts and the raster happened to pass over my screen byte at that point, do you not, would you get a glitch there?
Yeah, that's a great question. One of the things that by default is not fully synchronized is 6502 writes versus video reads. You can synchronize them to whatever granularity you want. That'll slow things down somewhat. The plan, the longer term plan for fast mode is that you actually only need to synchronize them when a frame is being displayed. So most of the time in fast mode, a frame is not being displayed, right? It runs at like 50,000 frames a second or something, or more. So most of the time you don't care about that. So you can actually do this sort of slow and accurate synchronized thing only when necessary, and then since that's one frame in a load of frames, it won't slow things down noticeably.